a research how how the sunflower moves around and track the sunlight. This plant species is actually famous for its heliotropic movement, heavenly movement. It always tracks the sunlight. So that's why we call it as sunflower. And you have seen this plant as a wheat plant on the roads as well as in your garden. And this is not the sunflower that is used for the commercial purpose. This is actually the sunflower for the aesthetic purpose as well. And the sunflower that is grown for the commercial purposes is different. It has a single very large head, and it always track the wild sunflower track the sunlight, but this commercial sunflower, when it has a very big head and the heavy head, it stop tracking the sun. So there could be many breeding objectives of the sunflower, like the high yield potential, development of sunflower hybrids, and biotic and abiotic resistance. And out of that, one of the breeding objective is to modify the oil quality. The oil quality is determined by the fatty acids. We will discuss later. Oil is made from different fatty acids. Like the proteins are made from the amino acids. The carbohydrates are made from monosaccharides. DNA is made from the nucleotide. The oil is made from the fatty acids, by joining different fatty acids. So different species have different kinds of fatty acids. The sunflower fatty acids, they are also specific. So we take up one of the breeding goal of the sunflower is to increase the high oleic acid. High oleic acid, or you can say oleic acid, is a omega-9 fatty acid. Omega-9 fatty acids. It is neither a saturated fatty acid or neither a polyunsaturated. It is in between, that is the monounsaturated fatty acid. And our goal was to increase the concentration of oleic acid in sunflower. I will discuss later what was the initial level of the oleic acid, and after breeding, how much we improve the oleic acid contents. So can I move to the next slide? Roadside sunflower. It has a very large head that is that have a lot of achenes within it. We call this sunflower as the seed of the sunflower as achene. And this achene is a multiple purpose in the industry. Like the achenes can be used for extracting the oil, and its seed cake can be used for making different feeds of the animals. And the sunflower can also be used for roasting purpose. Like you take the peanuts in the summer, you can also enjoy and relish with the sunflower seed as well. You can roast it and have you can taste the nuts, or you can say you can use this seed as an alternative to the nuts. Then you can also the sunflower could also be used in different confectionery purpose. So this sunflower crop in Pakistan, it is grown in February season as a spring crop, and in August as a autumn crop. In addition to the Pakistan, it is also been cultivated in more than 70 different countries of the world. The Russians and the Argentinian and the Croatians, they produce the highest production in the world. The Russians and the Ukrainians and as well as Argentinian. They makes about 70% of the total world production. The sunflower is the fourth important oil seed crop as well. After the palm oil, soybean, canola, the sunflower occupies the fourth number, and it contribute around 10% of the total edible oil. And sunflower cultivation is generally being done by the hybrid seed. You know the hybrid seed? The hybrid seed is actually a cross between a female line and a male line. We generally cross it. And if you are a MSc student or BSc student, you know how to make a hybrid. Like single cross hybrid is a cross between a cytoplasmic male steroid line and the fertility restorer line. We cross them in the field and make a single cross hybrids. So why do we do have the hybrids? We do use hybrids for cultivation because they are more uniform, they are more high yield. Although the price of the hybrid seed is very high, you know, the maize is cultivated by the hybrid seed, and about 10 kg bag is nearly about 20,000 rupees in Pakistan, and the for the sunflower, it has been also cultivated by the hybrid seed, and we import the seed from USA and some other countries, and we have about the per acre recommendation for the hybrid seed is 2 kg, and the price is around 16,000 for those 2 kgs you have to pay. So the price is very high, but the yield is also very good, and uniformity is also very good. So there is a big scope for you people to have the breeding programs, and you can after your degrees you can go for a seed business plan, hybrid seed production plans. Next slide. So you know Pakistan import a lot of oil. We are an oil deficient country. 84% of our oil is imported, and this is imported from our brethren Islamic country, the Malaysia. We import palm oil. Palm oil is obtained from a fruit that is cultivated, the Alis goyensis plant that is cultivated in the tropical environment of the Malaysia and Indonesia as well. So they are the big exporter of the palm oil. In Pakistan, cotton seed was a major source of edible oil. Now we have two groups. In the winter, we grow Janshia and Napus. They are also provide us the oil that we do not use for the cooking purpose. So in Pakistan, we have per capita consumption is about 19 kg. Every person can eat about 19 kg of oil every year in Pakistan. So we generally spend a lot of money, the import bill of Pakistan is 3 billion, almost 3 billion. I wrote 2.42 billion. So this is a very huge money we are spending on importing the oil. Because we have a very big population, we cannot produce according to the quantity, and we have more lavish life. We generally you can say we generally likes to eat the fried foods, and for that fried foods we need lot of oil. We have to put lot of oil to fry samosas and many other things. So for that we need, and this happens at the cost of import. we have to spend several billion every year to import the sunflower, the oil, including palm oil and sunflower. We import both oil from the different countries. Move to the next slide. So sunflower seed and oil quality. What is within the sunflower seed and what kind of quality it has. This is our today's topic of discussion as well. So sunflower, depending upon its variety, an oilseed sunflower contains about 20% protein, and if you average it, 40% oil, 20% protein and 40% oil. So the sunflower which is grown for confectionery purpose and for your roasting purpose, it may contains up to 30% proteins and 30% oil content. So it depends upon the variety you are going to grow. So if you are growing oilseed sunflower, you have to choose the varieties on the basis of the seed size. The oil types are smaller seeds with black testa, while those which are used for the confectionery or roasting purpose, they have larger seed and they have stripes on their testa. So sunflower, conventionally, sunflower oil is rich in polyunsaturated fatty acid. That is good for human health. Polyunsaturated fatty acid, as Khurram has told you, that they are very good for human health. You know, they are very good for the human health, but uh, uh, but they are not good for cooking. Why they are not good for cooking? The polyunsaturated fatty acids, because when you give a heat to that oil during the cooking, they will be burned. They will burnt away. So that's why we do not recommend to have very high polyunsaturated fatty acid in the cooking oils. It is good for human health if you use as a salad spread over it, or you just take a spoon of oil. If it is rich in polyunsaturated fatty acid, it's good for your health. It will give you a lot of health benefit. It contains vitamin A and E and many other things. So you may take it, but for the cooking purpose, we need those oils which are resistant at a very high temperature. And unfortunately, those oils which are high in polyunsaturated fat, they are not resistant for the cooking. Like you can say the linseed oil is an example. It contains omega-3 alpha-linolenic acid. It's rich in oil, and it is the most precious and the most, you can say, delicate oils we have. They have more delicacy because we because of the rich in polyunsaturated fatty acid, alpha-linolenic acid, that is very good for human health. You know, within the body, we do require a very high amount of alpha-linolenic acid, and linseed and the fish meat is a very good source of alpha-linolenic acid. But we cannot use it as a cooking medium because whenever there is a cooking, we cannot use it. There will be the heat at high temperature, more than 100 degrees centigrade, and that oil which is rich in polyunsaturated, it cannot endure that height. So in addition to the sunflower, the oils and fatty acids, proteins, it also contains the sterols, which are antioxidants. They improve the shelf life of the oil, as well as they also a good source of antioxidants for us. Then it also contains some very good minerals like the iron, magnesium, zinc, copper. And if you take the sunflower seed, it may give you some precious minerals to your body. Next slide. So you could see here in the slide, you could see that the commercial sunflower oil contains about 70% linoleic acid. Linoleic acid is conventionally sunflower is rich in linoleic acid. It's also a polyunsaturated fatty acid, omega-6 fatty acid. It is good for even good for health, but it is not good for the uh, mm, for the uh, for the cooking. It's not. Linoleic acid is also polyunsaturated fatty acid, as I have told you earlier, that uh, with the high temperature, this linoleic acid would have more burning. If you see the kitchens where you generally cook the food, you could see here, if you use the sunflower oil or canola oil or cottonseed oil, you could see the steam or the fumes are coming out of the cooking, and this is because of the burning of the oil, and it is been burned because it contains some polyunsaturated fatty acids. So conventionally sunflower has about 70% linoleic acid. The second At the second number, the 20% is about it contains oleic acid. 20% of the oil is oleic acid. Then you have the 4% stearic acid. Stearic acid is an unsaturated fatty acid, and it has neither good effect or neither bad effect on human health. So some people are also saying that we need to breed the oilseed crops which may contains very high stearic acid. Stearic acid has very high resistance to the heat during the cooking, and it is present in a small quantity in sunflower oil, but we can improve its quantity through breeding or modifications. And the stearic acid is also present up to 20% in palm oil as well. There also, but breeding stearic acid crop is now gaining popularity, because you know that there is objection or criticism on the palm oil, is that although it is very good for cooking, but it has negative impact on human health. Like it contains lot of palmitic acid. Palmitic acid is also not good for human health because it is a saturated fat, and it is a low density lipid. It may clot in the veins of the human being, and it may cause different heart diseases. So one of the objective in the palm oil breeding is to roll over the palmitic acid and increase the stearic acid. So there the oleic acid can be improved through the breeding, and we can have two kinds of sunflower oil. One would be the mid oleic acid, an oleic acid which contains 50 to 60% of oleic acid. Another kind of oil are those like high oleic acid, which have more than 70 or 80% of oleic acid. And it has been found that this third kind of sunflower would have a better resistance and more oxidative stability during the extraction and after within the packaging. It has more shelf life, as well as it will show more stability during the cooking. So this oleic acid increase happens at the expense of linoleic acid. More you have oleic acid, lesser you will have linoleic acid. And this oil is recommended for the cooking purpose. And there could also be some increase in the stearic acid as well. Like the higher you can develop the sunflower lines with high oleic acid as well as with good amount of stearic acid, like 18% or 20%, which is present in the palm oil as well. So you could see here the mid oleic acid is very tasteful. which contain 50 to 60% of oleic acid, has a very good taste. And this oleic acid percentage matches to the olive oil. Or olive oil also contain 50 to 60% of oleic acid, and it is the tastiest oil ever in the among the oilseed crops. Another good oilseed crop in Pakistan, which has very low yield potential, and it is being present in the arid zone, is sesame. Sesame is also very good oilseed crop. Move to the next slide. So we are now having the introduction, and now we are going to make a problem statement of the problem. Is that one is that we have a considerable gap in oil production. We are importing oil, and the thing is that there is inverse relationship between cooking quality and nutritional value. Those oils which have very high nutritional value, they are not recommended for the cooking purpose. They are not recommended for the cooking purpose. Like I told you, I give you an example like the linseed oil, the most delicate oil in the oilseed crop. You cannot use it for the cooking purpose. The sunflower oil is also very rich in nutrition and high polyunsaturated fatty acid. But we want to reduce these polyunsaturated fatty acid. Although they have a beneficial effect, we want to modify it with the oleic acid. The oleic acid is more stable than the linoleic acid, but it has nutritional value as well. Like it reduces the low density lipids within the human body, and it has a good impact on the human health. Next slide. So I have told you about the fatty acids, and there are you can say different species have different fatty acids. Like the palm oil is rich in palmitic acid. Sunflower is rich in linoleic acid. The cotton is also rich in linoleic acid. The olive is rich in oleic acid. Sesame is rich in oleic acid. So where we determine it? We determine it on the gas chromatography machine. We inject through there is a hole being present within on the screen you are seeing this gas chromatography machine. Here we inject very small amount of methylated oil. We remove the glycerols within the oil. Oil is a mixture of glycerol and fatty acid. What we extract from the plant, it is a mixture of two things. One is glycerol and other is the fatty acid. So we remove the glycerol and we feed a pure, you can say, sample of fatty acids. We inject it into the gas chromatography machine, and it gives you, it matches with the standards. It makes a peaks on the screen, and it will give you the fatty acid profile of any sample. In addition to that one, you can also use different markers as well, breeding markers like SSR markers or SNP markers to select a specific kind of oleic acid, what we used in our study as well. So this is a small machine, which a desktop machine, which is present. It is run by a carrier gas. We call it as a helium gas, or sometimes we use the nitrogen gas. This is powered by the gas, and we heat this machine heats the sample, and after that its detector detects the fatty acids and give us the sample will give you what kind of material it has. Next one. So I have told you earlier that why we want to breed high oleic acid crop, we want to have an oxidative stability. So here is the map that shows you the polar compounds in an oil that was extracted from the Hyson 33. Hyson 33 is a sunflower oil. And you could see here there is a very high increase in uh, the total polar compounds. These total polar compounds means more you have total polar compounds, lesser you have oxidative stability. जितनी ज़्यादा polar compounds होंगे after the frying, if you test before the frying and after the test, you could see a marked increase, several time increase in the total polar compounds. These polar compounds shows that higher the polar compounds, higher the oil is unfit for the cooking. Like this oil was extracted from Hyson 33. This is a ICI hybrid. This hybrid is S278, and this is a Syngenta hybrid. Okay, and this also you could see here in the gray bar there was a marked increase in the total polar compounds after the frying. Frying hours about 3-4 hours frying. You could see very high amount of total polar compounds. And in the end, you could see an olive oil. This olive oil is having the lesser amount of total polar compound, and this is because its fatty acid profile is different from that of the other sunflower different variety. This sunflower oil was a refined sunflower oil we obtained from the market, and when a student heat that oil or fried that oil for several hours, and after that we determine its polar compound, there was a several fold increase in the total polar compounds, and this is actually been the you can see this is indicative that the oil was actually rancidify. We use the term rancidification, or you can say the discharge of the harmful radicals during the cooking. And this is not only good for the oil shelf life itself, but these harmful radicals are also not good for the human health. So you could see the olive oil cooking is more safer than the sunflower, and this is because I have told you that it contains very high amount of oleic acid. Next slide. So here, what you can say, it may water your mouth, and you could see the cooking, deep frying. And for that, we need lot of oil, several kg of oil every day. Even in Ramadan, your budget generally increases because there is more frying in the Ramadan. So we are a nation that is turning towards that relishes the fried foods. And this oil is generally of low quality. If you are cooking in the palm oil, that is harmful for your human health. And if you are cooking in sunflower oil, although it is not very harmful for the human health, but it is very expensive. The oil would be burned, and it will rancidify during the cooking, and it may also discharge some harmful radicals, some like the oxygen radicals. Oxidation would occur not during the frying, but when you are storing it in an open container. Next slide. Next. So how we generally will modify the sunflower oil? The simplest answer is that we will make a change within the DNA of the sunflower. Whenever you need a heritable change within the plant, you need to modify it either through a conventional crossing between two parents, or you may use some mutagen, or you use some genetic engineering like CRISPR.